48 years ago, the universe seemed to whisper. Not with light, not with matter, but with a single, piercing radio cry that lasted just long enough to shake the foundations of what we thought we knew. It was August of 1977 when that whisper reached Earth. A radio telescope in Ohio caught a narrow-band signal unlike anything ever detected before. 72 seconds of soundless intensity. Then, silence. No repeat, no echo, nothing but an enigmatic trace printed on old computer paper and the astonished reaction of the astronomer who scribbled a single word beside the numbers. Wow! The story might have ended there, tucked away in the archives of astronomy, another anomaly in a universe full of mysteries. But the cosmos has a way of circling back. Nearly half a century later, from the very same patch of sky, something else has arrived. Not a faint radio hum this time, but a physical object, a messenger that streaks through the darkness of interstellar space and crosses the boundary into our solar system. Scientists call it 3 Atlas. It is only the third confirmed interstellar visitor ever seen, and it carries with it chemistry that defies the rules we thought were constant and a trajectory that seems almost deliberately timed. The parallel is almost too much to ignore. A mysterious signal in 1977, followed by a wandering object in 2025, both traced back to Sagittarius, the constellation that points directly toward the crowded heart of our galaxy. Was this coincidence, or was the universe trying to tell us something? That is the question that drives this story. 2 mysteries, one celestial return address, separated by decades, bound together by our relentless search for meaning in the chaos of the cosmos. Sagittarius is not just another constellation etched across our skies. To gaze in that direction is to look toward the galactic center itself, toward the supermassive black hole that anchors the Milky Way and the maelstrom of stars, gas, and radiation that surrounds it. For decades astronomers have debated whether this region, rich with energy and complexity, might be the most likely place to find a signal from another civilization. And so when the WOW signal came from Sagittarius, it felt almost too perfect, like a puzzle piece that had finally been set down, though the picture it belonged to remained hidden. Now, with 3 Atlas, the mystery deepens. Discovered on July 1, 2025 by the Atlas survey in the Chilean desert, this object is no ordinary comet or asteroid. It moves on a hyperbolic path, meaning it is not bound to our sun at all. It came from somewhere else entirely, slipping into our system for a brief encounter before it will return to the interstellar void. Its orbital eccentricity is greater than 1, the mathematical proof of its alien origin. And what makes it especially tantalizing is not only where it came from, but what it appears to be made of. Early measurements stunned researchers. Spectroscopy suggested an unusually high ratio of carbon dioxide to water vapor, roughly 8:1. Most comets from our own system favor water over carbon dioxide by a wide margin. This strange inversion suggested a birthplace around a star very different from our own, perhaps hotter, perhaps older, perhaps enriched with elements in ways our system never was. And then there were the metallic signatures. Nickel lines appeared in the comet's coma without the expected iron that should accompany them. It was as if the rules of chemistry had been bent, or rewritten entirely. The object itself was small, far smaller than most comets that display such vivid activity. Hubble measurements suggested a diameter no greater than 5.5 kilometers, possibly much smaller. And yet its output of dust and gas rivaled comets many times its size. Some astronomers called it overperforming, a polite way of saying it did not fit the mold. It was a puzzle piece that refused to match the others in the box, but one that demanded we pay attention. For those who remembered the WOW signal, the parallels were irresistible. That transmission, too, had seemed to defy natural explanation. Narrow band, intense, centered on the hydrogen line at 1420 MHz, the frequency SETI researchers had long considered the logical choice for interstellar communication. It lasted exactly as long as the telescope's beam would have scanned that portion of sky. It appeared once, never again, as if someone had whispered into the dark just as we were listening, then vanished forever. Scientists caution against overinterpretation. The history of astronomy is full of anomalies that later found natural explanations. Pulsars were once thought to be alien beacons before they revealed themselves as rapidly rotating neutron stars. Fast radio bursts caused similar excitement until better data pointed toward natural origins. And yet, the wow signal lingers because no conventional explanation has ever fully satisfied the evidence. Comets, satellites, atmospheric noise, all have been proposed, all found wanting. The simplest truth is that we still do not know what caused it. So here we are again, decades later, staring at a new anomaly from the same celestial direction. 3 Atlas and the WOW signal share a return address written across the sky in the shape of Sagittarius. And we are left to wonder, is this coincidence stacked upon coincidence, or are we glimpsing the first hints of a communication that spans light years and lifetimes? The human brain is wired to find patterns, to weave meaning from randomness. But sometimes the patterns are real. Sometimes the universe does speak, and we have to decide whether we are ready to listen. This documentary will not leap to conclusions. It will walk carefully through the evidence, from the first nights of Big Ear listening to the newest spectra captured by the James Webb Space Telescope. It will balance speculation with rigor, awe with skepticism. But it will not ignore the pull of the questions at the heart of this story. What if the WOW signal was never an accident? What if 3 Atlas is not just another interstellar rock but part of a larger message? And what if, after all these years, we are finally standing at the threshold of first contact, even if we do not yet recognize the door? For now, we begin at the beginning. The night of the WOW signal. The moment when a tired volunteer astronomer in Ohio reached for a red pen and changed the history of SETI with a single handwritten word. It was August 15, 1977. While most of America slept through an ordinary summer night, the Big Ear radio telescope in Ohio kept its silent vigil. Unlike the elegant dishes we picture when we think of radio astronomy, Big Ear was an odd creation, a giant metal trough embedded into the ground, stretching longer than 3 football fields. It did not swivel or pivot like modern telescopes. Instead, it used the rotation of Earth itself to sweep the heavens across its fixed reflectors, catching faint signals from distant space as the planet turned beneath the stars. Every night, every patch of sky received one chance, 72 seconds of exposure as the telescope's narrow beam moved across. Then the sky was gone, not to be seen again for another 24 hours. On that particular night, as the constellation Sagittarius drifted into the field of view, the receivers registered something extraordinary. The signal that appeared was narrow, precise, and strong, so strong it did not belong in the background noise of the universe. At 1420.455 MHz, it fell almost exactly on the hydrogen line, the universal frequency scientists had predicted decades earlier would be the most logical hailing channel for interstellar communication. The intensity climbed steadily, peaked, then faded away exactly as the telescope's geometry would predict for a real astronomical source. And then, silence. In the following days, volunteer astronomer Jerry Emmons sat down to review the computer printouts. The primitive system converted signal intensities into letters and numbers, filling rows of data that usually looked like endless sequences of 1s and 2s. But that night, buried in the pages, he saw something that stopped him cold. A sequence of 6 characters that rose and fell in symmetry, representing a signal nearly 30 times brighter than the background. 6EQUJ5. He grabbed a red pen, circled the string, and wrote one word in the margin. Wow! That handwritten exclamation would become one of the most famous annotations in the history of astronomy. The WOW signal, as it came to be called, seemed to embody everything SETI researchers had dreamed of, a powerful, narrow-band transmission, originating from space, at the hydrogen line, lasting exactly as long as the telescope could have seen it. It was a textbook case of what a deliberate extraterrestrial transmission might look like. And yet, it happened only once. The design of Big Ear created both the miracle and the curse of the discovery. Because it had 2 feed horns positioned side by side, any real cosmic source should have appeared twice, once in each beam about 3 minutes apart. The WOW signal appeared in only one beam, creating ambiguity about its exact location. And because the telescope could not be steered, follow-up observations had to wait until Earth rotated back into position the next night. By then, the signal was gone. The team at Ohio State scrambled to investigate. Over the next weeks and months, they pointed every available telescope back toward Sagittarius. They heard nothing. The WOW signal had vanished as suddenly as it had appeared. This silence only deepened the mystery. Natural sources usually repeat. Pulsars pulse, variable stars vary, masers flare. Even exotic phenomena like gamma-ray bursts occur in clusters. A one-time signal that never returns is hard to classify. Too anomalous to ignore, too isolated to accept as proof. Speculation flourished. Some proposed that it was an unknown astronomical event, perhaps a cloud of hydrogen illuminated by a passing flare, or a new kind of stellar activity. Others wondered if it might have been interference from Earth itself, a satellite or reflection from aircraft. But each explanation faltered against the data. The frequency was too exact, the profile too symmetrical, the intensity too high. The signal behaved like something intentional. Yet the absence of repetition left nothing to confirm. Over time, the WOW signal became both a symbol and a cautionary tale. For the public, it was the closest humanity had ever come to hearing from another intelligence. For scientists, it was a reminder of the standards required for extraordinary claims. One event does not make a discovery. Without replication, without a second detection, the WOW signal could never be more than an open question. And yet, it refused to fade. Decades later, reanalyses of the original data only reinforced its peculiarity. In 2024, using advanced processing techniques, researchers narrowed its possible origin to a region of sky just 8 arc-minutes across, a tiny slice of Sagittarius. They confirmed the extraordinary intensity, one of the strongest signals ever recorded from beyond the solar system. They even found subtle hints of surrounding structure that suggested something more complex than a simple burst. But the signal never repeated. And so the WOW signal has lived in the strange purgatory of scientific anomalies. Too significant to dismiss, too isolated to prove. It remains a singular event, a riddle written in hydrogen, waiting for context that might never come. This is the shadow under which the discovery of 3 Atlas now falls. When scientists realized that the new interstellar object was approaching from Sagittarius, memories of the WOW signal came flooding back. The coincidence was impossible to ignore. The same sky, the same constellation, the same mysterious direction. Suddenly, the anomaly from 1977 did not feel so isolated. It had company. Skeptics caution against making too much of this. Sagittarius is vast, spanning 30 degrees of the sky. Saying that 2 anomalies come from that direction is like saying 2 strange sounds came from New York City. The region is crowded, noisy, and full of energetic phenomena. Yet the parallels persist. The WOW signal was centered almost exactly on the hydrogen line, the frequency SETI researchers call the water hole. 3 Atlas carries chemistry that inverts our expectations, with carbon dioxide dominating water, a signature that seems to speak of a world unlike our own. Both are once-in-a-lifetime events, both traceable to the same direction, both timed in ways that stretch coincidence. So was it coincidence? Or was it something more? As the world watches 3 Atlas arc toward its close approach, the old printout with its red scrawl suddenly feels relevant again. A relic from a night nearly half a century ago that may yet connect to the present. Perhaps the universe has been whispering to us longer than we realized. Next, we will step deeper into the hydrogen line itself, the universal beacon that scientists have long believed would be the natural choice for interstellar communication, and the very frequency where the WOW signal appeared. Across the vast ocean of the electromagnetic spectrum, every frequency carries its own story. Some are filled with the chaotic noise of pulsars, quasars, and galaxies churning in the darkness. Others hum with the faint hiss of cosmic microwave background, the ancient afterglow of the Big Bang. But there is one frequency that stands apart, one so inevitable and so universal that scientists have long argued any intelligent civilization would recognize it. That frequency lies at exactly 1420.405755 MHz, known as the hydrogen line. Hydrogen is the simplest element in existence and the most abundant. It is the building block of stars, the fuel of galaxies, and the raw material of life itself. Every hydrogen atom contains a single proton and a single electron. Once in a very long while, on average, once every 11 million years for a given atom, that electron flips its spin orientation relative to the proton. When it does, the atom emits a precise quantum of energy in the form of a radio photon. That photon carries a wavelength of 21 centimeters. Across the universe, wherever hydrogen clouds stretch for light years, countless atoms undergo this rare flip. Their collective effect creates a faint but steady radio emission at 1420 MHz. In other words, the hydrogen line is nature's calling card. It is written into the physics of the universe. Any civilization that develops radio astronomy will inevitably discover it. They will measure it, study it, and realize its significance. It is a constant, a cosmic landmark that no culture, no biology, no technology could miss. This realization struck early SETI pioneers like lightning. In 1959, Giuseppe Cacconi and Philip Morrison published a paper that essentially founded the field of modern SETI. They argued that if an extraterrestrial intelligence wished to announce itself, the hydrogen line was the obvious frequency to choose. It was a universal beacon, a channel every radio-capable species would know to monitor. It was, in their words, the interstellar equivalent of a common language. The poetic symbolism only deepened the allure. At 1420 MHz lies hydrogen, at around 1660 MHz lies hydroxyl. Together, H and OH form water, the molecule most essential to life as we know it. SETI researchers began to refer to the region between them as the water hole, a natural meeting place in the spectrum where intelligent beings might gather their signals just as earthly animals gather around watering holes. It was the quietest band in the sky, shielded from much of the natural cosmic noise, ideal for long-distance communication. And so, when Jerry Emmons circled those numbers on his printout in 1977, and when researchers realized the WOW signal had come in almost exactly at the hydrogen line, the effect was electrifying. It was precisely the sort of frequency they had predicted. Narrow, intense, positioned at the universe's most logical hailing channel. The odds of that being random seemed almost impossible. Of course, the same qualities that make the hydrogen line so attractive for communication also create a challenge. Nature itself can produce signals at this frequency. Hydrogen masers, cosmic radio lasers triggered under certain energetic conditions, can create narrowband emissions that mimic what we might expect from artificial sources. They have been observed in star-forming regions, around evolved stars, and in the remnants of supernovae. A magnetar flare or a passing shockwave could, in theory, trigger transient maser activity that looks remarkably like a deliberate transmission. This is what some modern reanalyses have suggested for the WOW signal, that it may have been a natural hydrogen maser, a one-time flare created under exotic but ultimately natural conditions. But even that explanation leaves a sense of unease. If it was a maser, it was unlike any previously documented. Its precision, intensity, and timing seemed almost too perfect. As one astronomer noted, it stretched coincidence to its breaking point. The problem of natural mimicry has haunted SETI ever since. The very frequencies where we most expect to find intelligent signals are also the ones where nature sometimes cries wolf. Separating genuine technology from sophisticated natural phenomena becomes the central challenge. Researchers have developed strategies: look for repeatability, search for modulation, examine polarization, study frequency drift. But in 1977, none of those options were available. The WOW signal appeared, once, perfectly placed, and vanished. This is why the hydrogen line remains at the heart of SETI. Even today, projects like Breakthrough Listen devote enormous observing time to it. China's FAST telescope spends countless hours monitoring it. Because despite the risk of false alarms, it still makes the most sense. If we ever decide to broadcast our presence to the galaxy, many proposed schemes involve transmitting at the hydrogen line. It is the cosmic equivalent of dialing 911, a frequency that anyone with radio knowledge would instantly recognize as intentional. So what does this mean for 3 Atlas? As the object was discovered and its strange properties came into focus, astronomers began to wonder whether it might somehow tie back to that original signal. If an intelligent species had sent a message in 1977, what if the next stage of that message was not another radio transmission but something physical? A probe, a package, a comet-shaped messenger that would take decades to arrive. And what if it appeared in the sky from the very same direction as the hydrogen line whisper? Skeptics urge caution. The hydrogen line might be universal, but coincidences happen. Sagittarius is a huge portion of the sky, crowded with countless stars and clouds of gas. Interstellar debris passes through from all directions. The fact that 3 Atlas comes from Sagittarius could be nothing more than random chance. Its strange chemistry could be natural, its overperformance nothing more than a quirk of physics we have not yet encountered. And yet, the narrative is difficult to ignore. First a message at the universal beacon frequency, then an interstellar visitor with inexplicable traits, both from the same region of sky, separated by less than half a human lifetime. If the WOW signal was a call, is 3 Atlas the response? If the hydrogen line was the phone number, is this the knock at our door? The scientific method demands humility. We must remember that extraordinary claims require extraordinary evidence. Yet science also demands curiosity. To dismiss patterns too quickly is to risk overlooking discoveries that could redefine our place in the cosmos. The hydrogen line may be crowded with natural noise, but it may also be the one channel where someone else is trying to speak. In the next part, we will return to the WOW signal itself and explore the one feature that has defined it for nearly 50 years, its refusal to repeat. In science, reproducibility is everything. Without it, even the most tantalizing evidence remains forever an open question. In science, reproducibility is everything. A discovery that cannot be repeated, no matter how spectacular, will always remain suspect. This is the dilemma at the heart of the WOW signal. It appeared once, shone with extraordinary clarity, and then never returned. That single burst of radio energy has haunted astronomers for nearly half a century because its isolation makes it both deeply intriguing and profoundly frustrating. The follow-up began almost immediately after Jerry Emmons' red pen immortalized the data in the margin. The Big Ear team at Ohio State spent weeks rescanning the same region of sky as Earth's rotation brought Sagittarius back into view. Night after night, the telescope listened. The result was silence. No echo of the original signal, no hint that anything unusual had ever passed that way. As the years went on, other observatories joined the hunt. The Very Large Array in New Mexico turned its immense network of dishes toward the coordinates. The mighty Arecibo dish in Puerto Rico, at that time the most sensitive radio telescope on Earth, swept the area with painstaking care. Observatories in Australia added southern hemisphere coverage. At times the searches were continuous, at times intermittent, but across decades, the pattern remained the same. Silence. The longer the silence persisted, the more the mystery grew. If the WOW signal had been a natural phenomenon, why had it not repeated? Even the most exotic astrophysical events, magnetar flares, maser bursts, or transient hydrogen clouds, tend to occur more than once, either periodically, or in clusters. A solitary 72-second signal with no recurrence was hard to explain. If it had been artificial, one might expect continued transmissions, or at least a chance of hearing it again when conditions aligned. But again, nothing. By the early 21st century, many researchers began to treat the WOW signal as more of a curiosity than a candidate for serious extraterrestrial origin. Perhaps it had been an instrumental glitch. Perhaps a piece of terrestrial interference had slipped past unnoticed. Some even suggested mundane sources like aircraft reflections or misbehaving electronics. With no repeat, the possibilities could never be ruled out. And yet, the signal resisted dismissal. In 2024, a team of scientists reanalyzed the original Big Ear archives with modern processing techniques. What they found reignited debate. The signal's intensity was confirmed to be even stronger than earlier estimates, placing it among the most powerful radio bursts ever recorded from beyond the solar system. The team narrowed its probable source to a region only 8 arc-minutes across, a patch of sky smaller than a quarter of the full moon's diameter. That kind of precision ruled out many forms of terrestrial interference. More intriguingly, subtle enhancements were discovered at nearby frequencies, suggesting the signal might have been part of a more complex structure rather than a lone spike. One hypothesis gained traction: the signal might have been a transient hydrogen maser triggered by a rare cosmic event. Masers can produce narrowband emissions that mimic artificial signals. But the energy required to create one strong enough to match the WOW detection would have been enormous, comparable to stellar explosions. And no such event was ever observed in optical, X-ray, or gamma-ray data from that region of sky in 1977. The maser explanation, while plausible, still stretched coincidence uncomfortably far. This inability to settle into either category, natural or artificial, has kept the WOW signal alive in scientific and public imagination alike. Too structured to be dismissed as noise, too fleeting to be confirmed as intelligence, it lives in the liminal space of science, a riddle without an answer. It also highlights a deeper truth about how our species approaches anomalies. Human beings are pattern-seeking creatures. We are wired to detect significance, even in randomness. We see faces in clouds, shapes in shadows, conspiracies in coincidences. The WOW signal sits squarely in this psychological tension. Was it truly meaningful, or did our brains simply rebel against treating such a perfect alignment of factors as chance? The timing compounds the tension. In 1977, Earth had only been capable of radio astronomy for a few decades. We had just begun scanning the skies with enough sensitivity to detect interstellar whispers. If another civilization had chosen that moment to send a brief hello, it would make perfect sense that we caught it once and never again. On the other hand, the odds of catching a single one-off cosmic event right at the hydrogen line seem equally improbable. Either way, chance plays a role that feels almost impossible to accept. What makes the story even more compelling is that the WOW signal was not simply forgotten. It shaped the course of SETI research. It became the benchmark, the example by which future anomalies were measured. When fast radio bursts were first discovered decades later, many drew comparisons, asking whether they might be more examples of artificial communication. When new algorithms were designed to sift through radio data, they often used the WOW signal as a test case. Its legacy was not proof of aliens but proof of possibility. And so, when 3 Atlas appeared in 2025, carrying with it a set of anomalies just as perplexing, it was natural for astronomers to think back to the WOW signal. 2 isolated mysteries, both pointing toward Sagittarius, both raising questions that conventional science struggles to answer. Alone, each is an oddity. Together, they form a pattern that is difficult to ignore. Still, the lesson of the WOW signal lingers: without reproducibility, caution is essential. 3 Atlas at least offers repeated observation. Unlike a fleeting radio burst, it will remain in our system for months, visible to our telescopes, measurable in detail. Its chemistry, its orbit, its behavior, all can be tracked and studied. If there is something extraordinary to be found, we will have the chance to find it. But before we dive into the story of 3 Atlas itself, we must pause to understand why Sagittarius matters so much. Why did both anomalies seem to point in that direction, and what is it about the galactic center that makes it both the most obvious and the most challenging place to search for signals from beyond? The answer lies in the crowded, violent heart of our galaxy, a region that has fascinated astronomers since the first radio waves from space were detected nearly a century ago. When ancient stargazers looked toward Sagittarius, they imagined the figure of a centaur archer, bow drawn, arrow aimed at the glittering heart of the Milky Way. They could not have known how accurate their mythic picture was. In truth, That constellation does point directly toward the galactic center, the gravitational anchor of our galaxy and one of the most extraordinary regions in the known universe. Sagittarius is not just another shape on the sky. It is a signpost pointing to 26,000 light-years away, where the Milky Way's core resides. There, hidden behind immense curtains of interstellar dust, lies a monster, Sagittarius A*, a supermassive black hole containing the mass of 4.3 million suns. Around it whirl countless stars, gas clouds, and exotic objects in a cosmic maelstrom unlike anything we see in our own quiet neighborhood of space. This region is an astronomer's paradox. On one hand, it is the noisiest place in the sky. Radio waves flood from pulsars, supernova remnants, and stellar nurseries. The sheer density of stars creates a chorus of overlapping signals. On the other hand, it is the most logical place to search for intelligence. If advanced civilizations wanted to place a galactic broadcast hub, they could do no better than the center. From there, one transmission could reach countless stars across the spiral arms. That duality, signal and noise, chaos and communication, makes Sagittarius so compelling. When Carl Jansky first detected radio waves from space in the 1930s, they came from the direction of Sagittarius. When SETI researchers mapped their search strategies, the galactic center featured prominently. It is the city square of the Milky Way, crowded, energetic, and inescapably important. This is why the WOW signal's origin in Sagittarius was so striking. Against the backdrop of all that natural radio chaos, something emerged that looked artificial, narrow, and precise. It was like hearing a perfectly tuned note in the middle of a crowded marketplace. For it to stand out at all, it had to be extraordinary. And now, decades later, 3 Atlas appears from the same general direction, carrying its own set of puzzles. But let us pause and consider what makes the galactic center so extreme. The density of stars there is almost unimaginable. In our part of the galaxy, stars are spread far apart, the nearest to our Sun is over 4 light-years away. Near Sagittarius A*, stars can be just a fraction of a light-year apart. Planets in such regions would live under constant threat of gravitational disruption. Their orbits could be stretched, broken, or stolen by passing stars. Radiation levels are equally intense. X-rays and gamma rays flare from collapsing stars and magnetars. Supernovae pepper the environment with energy. Magnetic fields twist and snap with violence that dwarfs anything in our local spiral arm. To survive there, any civilization would need extraordinary technology simply to protect its homeworld. And yet, that same density offers opportunity. For civilizations seeking to connect with others, the galactic center provides a natural gathering place. Thousands of star systems lie within close reach of each other, making communication and travel more efficient. A beacon placed there could broadcast to much of the galaxy at once, a lighthouse at the hub of the Milky Way. This is why SETI pioneers speculated that if we ever received a message, it might well come from Sagittarius. For all these reasons, the coincidence of 2 anomalies from that direction seems difficult to dismiss. Yes, Sagittarius spans a vast 30 degrees of sky, large enough to encompass countless phenomena. But both the WOW signal and 3 Atlas have been refined to narrower regions that overlap enough to raise eyebrows. The WOW signal's origin has been constrained to within 8 arc minutes. 3 Atlas's radiant falls into the same general slice of sky. Even if this is chance, it is the kind of chance that demands investigation. The significance deepens when we consider how objects travel. Anything reaching us from Sagittarius has passed through the most extreme environments in the galaxy. Gravitational fields have tugged at it, radiation has bombarded it, chemistry has been altered by conditions far harsher than our own. If 3 Atlas truly originated there, its unusual composition might reflect those journeys. Its dominance of carbon dioxide over water, its nickel without iron, its hyperactive behavior for its size, these might be fingerprints of a place very different from our solar system. Of course, one must be cautious. Constellations are illusions, patterns drawn from our perspective on Earth. Stars in Sagittarius lie at very different distances, some near, some far. To say two things come from Sagittarius is like saying two letters were mailed from New York City. They might come from the same borough or from entirely different neighborhoods miles apart. Still, direction matters. It frames our perception, and it frames the coincidence that continues to intrigue scientists and the public alike. The more we learn about interstellar objects, the clearer it becomes that they are not as rare as once thought. Until 2017, we had never seen one. Then Oumuamua arrived, long and mysterious, slipping through before we could fully grasp its nature. 2 years later, Borisov appeared, more conventional but still alien. Now 3 Atlas makes the third, and astronomers predict hundreds more will be found in coming decades as new surveys like the Vera Rubin Observatory begin their work. If 3 Atlas were ordinary, its presence from Sagittarius might not mean much. But it is not ordinary. Its chemistry and activity place it apart. Combined with the direction of its arrival and the echo of the wow signal, it becomes part of a larger pattern, one that forces us to ask uncomfortable questions. Are we seeing coincidence upon coincidence, or are we glimpsing the outlines of something intentional? The human brain resists dismissing such alignments as mere chance. Perhaps this is our evolutionary heritage, the survival skill of spotting patterns in the chaos of the savannah. But perhaps, just perhaps, in this case the pattern is real. Perhaps the wow signal and 3 Atlas are not 2 random events but pieces of a larger puzzle still unfolding. In the next part, we will trace the discovery of 3 Atlas itself. We will go to the night of July 1, 2025, when an automated telescope system in Chile first caught sight of an object that clearly did not belong to our solar system. From that moment, the race began to understand what exactly had wandered into our neighborhood, and why. The night of July 1, 2025 began quietly in the Atacama Desert of Chile. The air was dry and thin, the sky brilliantly clear, a perfect stage for one of the most ambitious asteroid watch programs on Earth. The Asteroid Terrestrial Impact Last Alert System, better known as ATLAS, had spent years sweeping the heavens in search of near-Earth threats. Its cameras scanned methodically, frame after frame, tracking the endless ballet of rocks and dust that circle our sun. For the scientists running the system, most nights ended with nothing unusual, just cataloged dots of light moving predictably through their ancient orbits. But that night, the software flagged something different. Against the fixed stars, a faint point of light shifted too quickly, too sharply. The automated detection system measured its motion and instantly marked it as an outsider. When astronomers ran the calculations, the numbers leapt off the page. This was no ordinary asteroid, no long-period comet falling back from the Oort cloud. Its trajectory screamed interstellar. Its orbital eccentricity was greater than 1, the unmistakable mathematical signature of an object not bound to our sun. It had come from somewhere else entirely. Within hours, word spread through the global astronomy network. The excitement was palpable. Only twice before in history had humanity confirmed an interstellar visitor, Oumuamua in 2017, and Borisov in 2019. Each had challenged our assumptions, each had slipped away too quickly for detailed study. But this new object, provisionally named 3I/Atlas, offered something different. It was still inbound, still approaching the sun, which meant we would have months to observe it in detail. This was an unprecedented opportunity to scrutinize a wanderer from another star system. Professional observatories turned their instruments toward it immediately. The James Webb Space Telescope began capturing infrared spectra. Hubble tracked its brightness and size. Ground-based telescopes from Hawaii to Spain to South Africa joined the hunt. Even amateur astronomers with high-powered equipment trained their lenses on the faint interloper. For once, the entire community moved as one, determined not to miss a moment. As data began to pour in, the picture became stranger. Spectroscopy revealed a composition that did not match comets from our solar system. The ratio of carbon dioxide to water vapor was astonishing, nearly 8:1. Most of our comets favor water by a wide margin, but this object seemed almost inverted. Where had it formed to produce such chemistry? Around a hotter star, perhaps, or in conditions alien to our own system's nursery? The Hubble images added another puzzle. They suggested a nucleus no larger than 5.6 kilometers across, with some models hinting it might be smaller than a single city. Yet despite its modest size, it was already displaying vigorous cometary activity. A broad coma of gas and dust swelled around it, and a tail stretched millions of kilometers into space. By the standards of our system, it was overperforming, producing more activity than its surface area should allow. Astronomers described it with fascination, even bewilderment. An interstellar rock that should have been quiet was putting on a show. Some speculated it contained unusually volatile ices that sublimated more easily than water. Others wondered if its internal structure was fractured or porous, giving it more surface exposure than expected. Whatever the cause, 3 Atlas refused to behave like the comets we knew. Adding to the mystery was its orbit. The object approached on a retrograde trajectory, meaning it was traveling opposite the direction of the planets and most solar system bodies. It skimmed along the ecliptic plane, like a car driving against traffic on a cosmic highway. Such an orbit was rare and disconcerting. Natural interstellar objects should arrive from random angles, scattered across the sky. For one to appear retrograde but nearly coplanar with our system seemed an unlikely coincidence. By midsummer, the comet's strangeness became headline news. Popular media declared it an alien messenger, a cosmic intruder, a riddle hurtling through the solar system. Scientists tried to temper the frenzy, reminding the public that unusual does not mean unnatural. But privately, even the most cautious researchers admitted that 3 Atlas raised questions they could not yet answer. The object's chemistry added fuel to the speculation. Infrared observations from Webb indicated strong nickel emissions without the expected iron lines. Nickel and iron usually appear together in cosmic materials, forged in the same stellar processes. Their separation in 3 Atlas defied conventional models. Some astronomers proposed that iron might be locked in minerals requiring higher temperatures to sublimate, meaning it could still emerge later as the object drew closer to the Sun. Others argued that it hinted at a formation environment radically different from our own, where nickel-rich but iron-poor conditions prevailed. Either way, the signature was odd enough to spark debate. For those with long memories, the coincidence was impossible to ignore. An interstellar object with anomalous chemistry, arriving from Sagittarius, nearly 50 years after the WOW signal had blazed at the hydrogen line from the same direction. 2 mysteries, decades apart, converging on the same patch of sky. For the public, it was a story too good to resist. For scientists, it was a reminder that coincidences sometimes matter. NASA quickly confirmed that 3 Atlas posed no threat to Earth. Its closest approach would come in December 2025, at a safe distance of 270 million kilometers, nearly twice the Earth-Sun separation. Still, the object's path would bring it close enough for detailed observation during several critical phases, a flyby near Mars in October, perihelion in late October when it would pass closest to the Sun, then its outbound leg past Earth and Jupiter before it disappeared forever. Each encounter offered a chance to gather data, to test theories, and perhaps to answer questions left hanging since 1977. For astronomers, it was the opportunity of a lifetime. For the public, it was the continuation of a mystery that had lingered for nearly 5 decades. Was 3 Atlas simply an exotic comet from another system, carrying the chemical fingerprints of its distant birthplace? Or was it something more, a probe, a messenger, a deliberate follow-up to the WOW signal? The answer, if one exists, lies in the details. And those details would begin to accumulate as the summer turned to autumn and the object drew closer, brightening, changing, revealing secrets in its tail and its spectra. The cosmos had delivered us a visitor from beyond, and for the first time, we had the tools to study it properly. In the next part, we will explore the anomalies that began to surface as astronomers gathered more data. The chemistry, the orbit, and the behavior of 3 Atlas only deepened the mystery, leading some to whisper that perhaps, just perhaps, it was not entirely natural. As the weeks of observation rolled on, 3 Atlas began to reveal itself piece by piece, and with every new dataset the questions multiplied. By late summer of 2025, astronomers were no longer describing it as merely unusual. They were calling it baffling. Every telescope, every instrument seemed to return results that challenged long-standing expectations of what a comet should be. If this interstellar visitor was a messenger from another star, then it was delivering a message written in anomalies. The most striking revelation came from the James Webb Space Telescope. Using its powerful infrared spectrographs, scientists measured the gases streaming off the object as sunlight awakened its frozen interior. What they found left them stunned. The dominant volatile was carbon dioxide, and in quantities that dwarfed water vapor by nearly 8 to 1. This was the exact reverse of what we see in comets born within our solar system, where water is abundant and carbon dioxide plays a secondary role. This inversion was more than a quirk. It spoke to conditions at the comet's place of birth, conditions that must have been radically different from those in our own protoplanetary disk. Perhaps 3 Atlas formed around a hotter star, one that stripped water more easily while leaving carbon dioxide frozen. Perhaps it came from a system rich in heavy elements that skewed the balance of chemistry. Or perhaps it was forged in an environment we cannot yet imagine, one with rules alien to anything we have encountered. The chemistry was only the beginning. Hubble's imaging placed the object's diameter at no more than 5.6 kilometers, with some estimates shrinking it to a few hundred meters. Yet despite its small size, 3 Atlas erupted with activity far greater than such a body should be capable of sustaining. Its coma expanded to hundreds of thousands of kilometers. Its tail stretched millions of kilometers behind it. Observers described it as an overperforming comet, a phrase that masked their unease. Something so small should not have been able to generate such a display. Ground-based observatories added their own pieces to the puzzle. The Very Large Telescope in Chile analyzed the coma's light and detected bright nickel emission lines. That was not unusual by itself. Nickel often appears in cometary outgassing. But what was unusual was what was missing. Iron, nickel's constant companion in cosmic materials, was absent. The selective presence of one metal without the other contradicted what astronomers thought they knew about the way elements behave in these conditions. Some speculated that iron was bound in minerals that required higher heat to release. Others suggested a strange abundance ratio baked into the comet's origin. Whatever the explanation, it was another red flag. The object's orbit only deepened the intrigue. 3 Atlas was moving retrograde relative to the planets, skimming through the solar plane but traveling against the flow. While not impossible, such orbits are rare. To see an interstellar object arrive not from some random angle but aligned with our ecliptic, only in reverse, raised eyebrows. It was as though it had deliberately chosen to meet us head-on, like a car speeding the wrong way down a crowded freeway. Even its timing seemed suspect. 48 years almost to the day after the WOW signal, 3 Atlas made its appearance. Coincidence, said the cautious. But many admitted privately that it strained belief. In a universe of 2 trillion galaxies, each with billions of stars, what were the odds that 2 of the most perplexing anomalies in modern astronomy would not only share the same celestial return address but also fall within the same human lifetime? As these anomalies accumulated, so did the speculation. Most scientists stayed firmly grounded, emphasizing that nature often surprises us. Oumuamua had confounded expectations with its cigar-like shape and unexplained acceleration. Borisov had carried chemistry that hinted at different stellar nurseries. 3 Atlas might simply be another oddball in a growing catalog of interstellar wanderers. But others began to wonder aloud whether the pattern was too neat, the timing too sharp, the chemistry too strange to be entirely natural. One of the most vocal was Avi Loeb of Harvard University, already controversial for suggesting that Oumuamua might have been alien technology. He noted that the dominance of carbon dioxide could just as easily result from industrial processes as from natural condensation. He pointed to the nickel without iron as a possible sign of manufactured alloys. He even suggested that the object's apparent overperformance might reflect internal structures optimized not for random outgassing but for deliberate function. Mainstream astronomers pushed back hard. Jason Wright of Penn State reminded the community that extraordinary claims require extraordinary evidence, and that so far all we had were anomalies with potential natural explanations. Yes, the chemistry was odd, but comets from other stars should be expected to surprise us. Yes, the orbit was unusual, but rare does not mean impossible. And yes, the timing with the WOW signal was intriguing, but coincidence is not causation. Yet even skeptics acknowledged that 3 Atlas was special. Whether natural or artificial, it was unlike anything we had seen before. The combination of its chemistry, orbit, activity, and direction made it the most compelling interstellar visitor to date. For many, the object became less about proving aliens and more about pushing the boundaries of what we thought possible in cometary physics. Still, the allure of the unnatural never quite went away. Popular media latched on, splashing headlines about alien messengers across the internet. Documentaries speculated about probes disguised as comets. Social media buzzed with theories of contact. Scientists sighed, but they understood. The mystery was too perfect, too cinematic. A radio whisper in 1977 and a cosmic wanderer in 2025, both from the galactic center, both inexplicable. The story practically told itself. For those inside observatories, however, the focus was on the data. Every night, telescopes recorded spectra, images, and brightness curves. Every piece of evidence mattered, because in a matter of months the object would be gone forever. There would be no second chance. The deeper question loomed in the background. Was 3 Atlas simply another natural relic of a distant planetary system, or was it part of something larger, a story that had begun almost half a century earlier with a single word scribbled in red ink? That tension, between skepticism and wonder, defined every discussion. In the next part, we will return to Sagittarius itself, to examine how its role in this story complicates the question of coincidence and deepens the possibility that the galactic center might be more than just a backdrop. Perhaps it is the stage on which this cosmic drama has always been meant to unfold. In astronomy, coincidences can be deceiving. The sky is vast, and random alignments are bound to occur. Yet sometimes, patterns emerge that feel almost deliberate, as if the universe is nudging us to pay attention. That is the case with Sagittarius. Both the WOW signal and 3 Atlas trace back to this constellation, a fact that continues to provoke both skepticism and fascination. When NASA ran detailed trajectory analyses of 3 Atlas, they confirmed what initial calculations had suggested. The object's radiant, the point in the sky from which it appeared to originate, fell squarely within the region of Sagittarius. This was not a razor-sharp alignment. The WOW signal's origin had been narrowed to an 8 arc-minute patch, while 3 Atlas's radiant covered its own uncertainty ellipse displaced by a few degrees. Yet both pointed back toward the same broader sector of the sky. To astronomers, this constitutes what they call positional coincidence. The significance of such an overlap depends on scale. Sagittarius spans about 30 degrees across the sky, equivalent to the width of 60 full moons laid side by side. Within that vast area, countless stars, nebulae, and clusters create a backdrop crowded with activity. Statistically, about 7% of all celestial phenomena we detect could appear to come from Sagittarius by chance. On those grounds, some argue there is nothing extraordinary about 2 anomalies originating there. With such a large target, the odds were never that small. But Sagittarius is not just any constellation. It is the window into the galactic center, the most energetic and chaotic environment in the Milky Way. This region teems with radio sources, from pulsars to supernova remnants to dense molecular clouds. For SETI researchers, this makes Sagittarius both the best and the worst place to look for artificial signals. It is the galactic crossroads, where a beacon could reach the greatest number of civilizations, but also where background noise makes detection the hardest. This dual nature is what makes the coincidence so tantalizing. On one hand, it could simply be statistical happenstance. On the other, it could be precisely the kind of region where an advanced civilization might choose to broadcast or dispatch probes. If you wanted your signal to be heard across the galaxy, why not place it at the hub? If you wanted to send messengers, why not launch them from where stars crowd together in their millions? There is another layer: timing. The WOW signal appeared in 1977, then silence. Decades passed. Then in 2025, 3 Atlas appeared from the same direction. The universe is nearly 14 billion years old. Humanity has been listening for only about 70. What are the odds that 2 such anomalies would fall into that tiny sliver of history? For skeptics, the answer is obvious: improbable things happen all the time. For others, the odds feel uncomfortably slim, like flipping a coin and watching it land on its edge twice in a row. Galactic dynamics complicate the story further. Objects ejected from the crowded environments near the galactic center could take millions of years to reach our solar system. If 3 Atlas was thrown out of its home system long ago, its arrival in our time might be nothing more than cosmic roulette. Yet that randomness is what makes the coincidence so striking. Out of all the epochs of human history, why now? Why within a human lifetime of the WOW signal? One explanation is bias. We humans are natural pattern seekers. We connect dots, even when they may not truly belong together. Perhaps the WOW signal and 3 Atlas are unrelated, and we are imposing meaning where there is none. But there is another possibility: perhaps they really are part of a pattern, and our instinct to connect them is correct. For SETI researchers, the question has practical consequences. If signals or objects from Sagittarius deserve more attention, then resources should be directed accordingly. Already, telescopes are planning to monitor 3 Atlas closely as it approaches perihelion and then passes near Earth. Special attention will be given to frequencies around the hydrogen line, just in case the object has something more to say. Even if 3 Atlas proves natural, its coincidence with the WOW signal may highlight something important about Sagittarius itself. The galactic center is a region of extremes. Its stars are ancient and metal-rich, making them fertile ground for planetary systems. Its density increases the chances of interstellar exchange, with material flung from one system crossing into another. Perhaps the WOW signal and 3 Atlas both reflect this heightened activity, reminders that the galactic center is a crucible where the unusual is not only possible but inevitable. For the public, however, the coincidence is irresistible. News outlets frame the narrative as if it were a mystery novel: 2 anomalies, 1 constellation, decades apart. Social media speculates about alien probes disguised as comets. Documentaries paint Sagittarius as the stage on which humanity's first contact might play out. Scientists may bristle at the sensationalism, but they cannot deny the drama. Coincidence or not, the story captures imagination because it touches on our oldest questions: are we alone? If not, are they trying to reach us? The truth is that we cannot yet know. The statistical arguments for coincidence are strong. But so are the human instincts that rebel against writing it off. In a galaxy this vast, true patterns will be rare. That does not mean they will never appear. If the WOW signal was one anomaly and 3 Atlas another, then perhaps Sagittarius is simply where anomalies cluster. Or perhaps, more provocatively, it is where someone wants them to cluster. The debate will not end soon. It will intensify as 3 Atlas continues its journey through our solar system. If it behaves like a natural comet, the coincidence will fade into history as another unsolved riddle. But if it reveals something stranger, if it shows signs of artificial origin, if it emits signals, if it defies the explanations we reach for, then the directional overlap with the WOW signal will take on an entirely new significance. For now, all we can do is watch. And wait. And listen. Sagittarius remains the arrow pointing to the heart of the galaxy, and perhaps to the heart of the mystery itself. In the next part, we will trace the celestial timeline of 3 Atlas's journey, its encounters with Mars, the Sun, Earth, and Jupiter, and why each of these milestones could prove decisive in determining what kind of visitor has entered our neighborhood. Once astronomers confirmed that 3 Atlas was inbound on a hyperbolic trajectory, the next step was to chart its course with precision. Orbital mechanics may be complex, but it is also beautifully predictable. With enough observations, scientists could map out every twist of its path through the solar system, from its first brush with Mars to its final departure into the interstellar dark. What they found was a series of encounters perfectly timed to offer humanity a rare chance to investigate an interstellar wanderer in unprecedented detail. The first major milestone would arrive in early October 2025, when 3 Atlas swept past Mars at a distance of about 30 million kilometers. To the average person, that might sound impossibly far. But to planetary scientists, it represented a golden opportunity. Mars is a world with orbiters already in place, and those spacecraft were quickly tasked with observing the visitor. The European Space Agency confirmed that its Trace Gas Orbiter and the veteran Mars Express would attempt coordinated campaigns, capturing images and spectra from vantage points far beyond Earth's reach. For the first time in history, we would have multiple spacecraft positioned around another planet, ready to study an interstellar object up close. This encounter promised more than just pretty pictures. By tracking subtle gravitational effects on the spacecraft, scientists hoped to refine estimates of 3 Atlas's mass and density. If it proved lighter than expected, it might suggest a porous, fragile structure. If heavier, it could point to an unusually solid body. Either result would add critical context to its chemistry and activity. The Mars flyby also coincided with the comet's peak activity as it drew closer to the Sun. Spectroscopic readings during this period could reveal whether the puzzling nickel emissions persisted and whether the long-absent iron finally emerged. In short, October would give us the best chance to see what 3 Atlas was truly made of. After Mars, the object continued inward, aiming for its perihelion at the end of October. Perihelion is the moment when a comet orbits closest to the Sun, the point of maximum heating and stress. For 3 Atlas, calculations showed it would pass about 1.4 astronomical units from the Sun, inside the orbit of Mars but well outside Earth's path. Even at that distance, the intensity of solar radiation would be fierce. Any comet pushed to its limits will reveal secrets at perihelion. Some fragment. Some flare spectacularly. Others fade into exhaustion. If 3 Atlas hit anything unusual, this would be the moment for it to appear. The challenge, however, lay in visibility. From Earth's perspective, 3 Atlas would lie too close to the Sun in the sky during perihelion. Ground-based observatories would be blinded by glare. Only space-based telescopes with specialized shielding, like Hubble and Webb, could hope to watch. That meant competition for observing time would be fierce, and every minute would matter. Astronomers likened it to trying to examine a candle while staring directly into a spotlight. But they knew the effort was worth it. If the object's chemistry shifted dramatically, if new elements appeared, or if its brightness flared in unexpected ways, the data could prove decisive. Once past the Sun, 3 Atlas would re-emerge into the morning sky by early December, beginning its outbound leg. This phase carried its own milestone, the closest approach to Earth on December 19, at about 270 million kilometers. Again, the distance was far greater than those achieved by famous comets like Hale-Bopp or Hyakutake, which dazzled naked-eye observers. 3 Atlas would never shine bright enough to see without telescopes. But for radio astronomers, the geometry of this encounter was perfect. At that distance, signals from the object, if any existed, would be as strong as they could be. The Doppler effects of relative motion would be minimized, making it easier to analyze frequencies precisely. For SETI researchers, this was the golden window. Radio telescopes worldwide prepared to listen, many of them tuning specifically to the hydrogen line, hoping against hope for a repeat of 1977. Even silence would be meaningful, constraining what was possible. But if anything emerged, even a faint, structured signal, the implications would be staggering. After Earth, 3 Atlas's path bent outward, carrying it toward the gas giants. On March 16, 2026, it would pass within 0.36 astronomical units of Jupiter, roughly 54 million kilometers from the planet's cloud tops. This encounter fascinated dynamicists, who saw a chance to study how interstellar objects respond to the powerful magnetic fields of giant planets. Even from that distance, Jupiter's influence could alter the comet's coma and tail, creating natural experiments in plasma physics and chemistry. Some mission planners even floated the idea of redirecting existing spacecraft like NASA's Juno, though such maneuvers would be costly and risky. Beyond Jupiter, the opportunities dwindled. By late 2026, 3 Atlas would fade from view as it retreated into the outer solar system. Unlike comets bound to the Sun, it would never return. Its hyperbolic orbit guaranteed that this was a one-time encounter. Whatever we learned in that 18-month window would be all we would ever know. And so the urgency was immense. Every observation, every measurement carried the weight of finality. This timeline of encounters shaped not only scientific priorities but also public imagination. Each milestone became a chapter in an unfolding drama. October with Mars, late October with the Sun, December with Earth, March with Jupiter. Each step a chance for revelation, each a potential turning point. If 3 Atlas carried secrets, these were the moments when they might emerge. But there was another layer to the timeline, one that stretched beyond astronomy into the psychology of coincidence. The WOW signal had lasted 72 seconds. Then silence for 48 years. Now, just as 3 Atlas prepared for its encounters, SETI researchers were organizing the most intensive listening campaign in history. The overlap was uncanny. As the comet drew close, telescopes worldwide would be tuned to the hydrogen line once more, listening to the same sky, from the same direction, at the same frequency that had once whispered wow. For some, this felt like destiny. For others, it was nothing more than human projection. But either way, the alignment of history and trajectory was undeniable. The cosmos had given us a clock, and its hands were ticking. In the next part, we will explore the debates raging within the scientific community. For some researchers, 3 Atlas was nothing more than a natural comet behaving oddly. For others, it was a potential artifact, a probe disguised as a wanderer. The divide was sharp, and the stakes could not have been higher. In astronomy, disagreements are usually polite. Researchers publish papers, attend conferences, and argue their cases with equations and data. But 3 Atlas stirred something more volatile. Its unusual characteristics split the community into camps, each convinced the other was missing the point. What began as cautious analysis quickly escalated into a debate that spilled from journals into blogs, interviews, and headlines. The arrival of this interstellar wanderer had not only challenged our understanding of comets but had also exposed deep philosophical divisions about how science should handle anomalies. On one side stood the mainstream consensus, represented by institutions like NASA, the European Space Agency, and leading observatories. Their position was clear: 3 Atlas was natural. Yes, it was unusual, but unusual did not mean impossible. In fact, they argued, unusual was exactly what we should expect. We had only observed 2 interstellar visitors before, Oumuamua and Borisov, and both had challenged expectations in their own ways. With a sample size of 3, who could say what was normal? To declare an object artificial on such flimsy grounds was premature at best, reckless at worst. Alan Fitzsimmons of Queen's University Belfast summed it up bluntly. Studying 3 interstellar objects, he said, was like meeting 3 random people on Earth and trying to define human diversity from that tiny sample. Of course we would encounter outliers. Of course some would seem bizarre. 3 Atlas might look strange compared to comets from our solar system, but that did not make it alien. It simply reflected the diversity of planetary systems scattered across the galaxy. Backing this view were new measurements from Hubble, which seemed to resolve some of the mystery. Early reports had suggested 3 Atlas might be larger than its activity implied, sparking speculation about hidden structures. But refined data indicated a nucleus no larger than 5.6 kilometers, with some analyses favoring sizes as small as 300 meters. Smaller bodies have a higher surface area relative to volume, meaning they can release volatiles more efficiently when heated. The so-called overperformance might simply be the result of geometry. Others focused on the chemistry. The carbon dioxide dominance, while puzzling, could be explained by formation in the outer regions of hotter stars' disks. The nickel without iron could result from unusual mineral compositions or thermal processing that released nickel at lower temperatures while keeping iron locked away. None of these explanations required alien engineering. They required only humility in the face of diversity. Yet not everyone was satisfied. Avi Loeb of Harvard, never shy about courting controversy, argued that the anomalies demanded more radical consideration. He reminded his colleagues that Oumuamua had also been dismissed as natural despite unexplained acceleration and improbable shape. 3 Atlas, he claimed, showed a pattern of peculiarities too consistent to ignore. Its retrograde orbit along the ecliptic, its chemistry, its activity, and above all its timing with the WOW signal formed what he called a probability deficit. Too many coincidences stacked together demanded explanation. Loeb suggested the possibility of artificial origin, perhaps a probe disguised as a comet, perhaps part of a larger interstellar communication effort. He pointed out that carbon dioxide dominance could result from industrial byproducts as easily as from primordial conditions. Nickel without iron could indicate engineered alloys. The object's vigorous outgassing, he speculated, might be camouflage for controlled activity. While most scientists rolled their eyes at these claims, Loeb insisted that science required entertaining all possibilities, not just the comfortable ones. Jason Wright of Penn State countered forcefully. Extraordinary claims, he reminded audiences, required extraordinary evidence. And so far, all the evidence for artificial origin was circumstantial. Anomalies do not equal technology. Natural explanations, however unsatisfying, still covered every observed trait. Without controlled maneuvers, without structured radio emissions, without impossible materials, 3 Atlas remained a comet until proven otherwise. To leap to aliens was to undermine SETI by crying wolf. This back and forth highlighted a deeper divide: what should science do with anomalies? The conservative camp argued that history is littered with mysteries that once seemed alien but later proved natural. Pulsars, when first discovered, pulsed so precisely they were jokingly called little green men. Gamma-ray bursts were so powerful they seemed impossible until better models explained them. Fast radio bursts once baffled researchers but are now linked to magnetars. Each time, patience and data resolved the unknown without invoking intelligence. The progressive camp countered that clinging too tightly to natural explanations risked missing paradigm-shifting discoveries. SETI itself began because a handful of scientists dared to take seriously the possibility of extraterrestrial communication. If they had dismissed that idea outright, entire fields of research would not exist. Anomalies should not be ignored, they should be tested against all hypotheses, even extraordinary ones. Media coverage amplified the debate. Headlines swung between extremes. Some declared 3 Atlas the most likely alien probe ever discovered. Others mocked the idea as sensationalist hype. Television programs and documentaries leaned heavily into the drama, framing the comet as a potential messenger. On social media, the divide widened further, with enthusiasts proclaiming first contact and skeptics rolling their eyes. Inside the scientific community, the debate carried practical consequences. Funding agencies worried that too much speculation about aliens could tarnish legitimate astronomy. Others argued that ignoring the possibility entirely would stifle creativity and discourage bold research. The tension reflected not just differences of opinion but different visions of what science should be: cautious cataloging of the plausible, or daring pursuit of the extraordinary. Meanwhile, the object itself continued on its path, indifferent to the controversy it inspired. Each new observation added nuance but not resolution. Spectroscopic readings confirmed unusual chemistry but no definitive technosignatures. Brightness curves suggested rotation but not controlled motion. Radio searches returned silence, so far. The comet behaved like a comet, even as its quirks kept the door open for speculation. The stakes were clear. If 3 Atlas eventually displayed definitive artificial characteristics, controlled maneuvers, structured transmissions, or materials impossible to form naturally, it would be the discovery of the century, perhaps the millennium. If it continued to behave like a natural comet, the debate would become a footnote, a case study in how humans grapple with anomalies. Either way, the episode was forcing astronomy to confront its assumptions, its methods, and its biases. In the next part, we will step away from the debates and return to the larger question: coincidence or contact? Are we simply weaving patterns into randomness, or could the alignment of the WOW signal and 3 Atlas truly represent humanity's first brush with an interstellar message? Human beings are storytellers at heart. Our brains are wired to search for meaning, to connect the dots of experience into patterns that can guide us. This ability once kept our ancestors alive, allowing them to see the shadow of a predator in tall grass or recognize the signs of an approaching storm. Today, that same instinct pushes us to find coherence in the randomness of the cosmos. When confronted with 2 anomalies like the WOW signal and 3 Atlas, our minds struggle to accept that they might be unconnected. The coincidences feel too sharp, too orchestrated, too meaningful to dismiss. 2 events separated by nearly half a century, both traced back to the same region of sky, both resisting easy explanation. One was a whisper in radio frequencies, the other a tangible visitor from interstellar space. To many, the pairing suggests design, as though the signal was a greeting and the comet the follow-up, or as though both were pieces of a puzzle yet to be solved. But science demands restraint. To leap from coincidence to contact without evidence is to risk turning curiosity into fantasy. The WOW signal, for all its intrigue, has never repeated. Its exact position remains uncertain within several arc minutes. 3 Atlas's radiant covers a swath of sky a few degrees across. In cosmic terms, that translates to distances of light years. From that perspective, the alignment is not as precise as our pattern-seeking minds want to believe. Millions of stars lie in that direction, countless possible origins. To link them too tightly risks overstating the connection. Timing complicates matters further. If 3 Atlas has been wandering the galaxy for millions of years since its ejection from some distant system, its arrival now may simply be chance. The WOW signal could have been a transient maser flare from a hydrogen cloud, completely unrelated to any object. Both anomalies may share only the fact that humans noticed them. Yet our minds resist this conclusion. The universe is nearly 14 billion years old. Our species has been listening for signals for less than a century. What are the odds that 2 unrelated phenomena would appear within that brief window? This psychological tension has long haunted the search for extraterrestrial intelligence. We are caught between skepticism and hope. On one side lies the scientific requirement to avoid overinterpreting chance alignments. On the other lies the deeply human yearning not to be alone. When the evidence is ambiguous, as it so often is, we lean toward the interpretation that resonates most with our desires. For some, that means clinging to coincidence as the safest explanation. For others, it means entertaining the possibility of contact, however faint. Philosophers call this the problem of induction, the difficulty of drawing general conclusions from limited observations. With only 1 unexplained radio signal and 3 interstellar objects in human history, our sample size is too small for reliable statistics. Are such events common or rare? Do they cluster or disperse? We simply do not know. Until we build a much larger catalog of anomalies, each new case will feel more significant than it may truly be. Yet dismissing the correlation entirely requires its own leap of faith. In a galaxy with hundreds of billions of stars, perhaps intelligent life is more common than we assume. If even a fraction of civilizations attempt interstellar communication, then coincidences may not be coincidences at all but the faint outlines of a network we are only beginning to glimpse. From this perspective, the WOW signal and 3 Atlas could be 2 notes in a cosmic symphony, barely audible to us now but hinting at a larger score. This duality, coincidence or contact, fuels both scientific inquiry and public imagination. Scientists design experiments to test the possibilities, searching for radio emissions from 3 Atlas, monitoring its motion for non-gravitational accelerations, analyzing its chemistry for unnatural ratios. The public consumes documentaries and news articles, captivated by the idea that a comet could be a messenger. Both groups are driven by the same question: what if it is not just coincidence? The irony is that science advances whether the anomalies prove connected or not. If they are unrelated, the exercise still teaches us about the diversity of interstellar matter and the challenges of detecting signals amid cosmic noise. If they are connected, the implications would be revolutionary, forcing us to reconsider our place in the universe. Either way, the process of asking, testing, and refining deepens our understanding. Still, the emotional weight of the question cannot be denied. To imagine that another intelligence might have chosen to signal us, first with a burst of radio at the hydrogen line, then with a physical object decades later, is to imagine that we are not isolated in the cosmic dark. It is to imagine that someone is watching, waiting, perhaps even reaching out. Such thoughts inspire awe, but they also demand caution. History warns us that anomalies often yield to mundane explanations once enough data accumulates. Pulsars, gamma-ray bursts, fast radio bursts, all were once contenders for alien origin until natural processes were revealed. And yet, the WOW signal still stands apart, stubbornly unexplained, resistant to dismissal. 3 Atlas now stands beside it, a second anomaly from the same sky. Together, they form a story too compelling to ignore, even if the ending remains unwritten. Perhaps the coincidence is just that, coincidence. But perhaps, just perhaps, it is the first faint trace of contact. In the next part, we will explore one of the most daring ideas born from this pairing, the message-in-motion hypothesis. What if the WOW signal was not the end of the story but the beginning, a radio announcement followed by a physical follow-up? Could 3 Atlas be more than a rock? Could it be a messenger on a mission across decades and light years? Human beings are storytellers at heart. Our brains are wired to search for meaning, to connect the dots of experience into patterns that can guide us. This ability once kept our ancestors alive, allowing them to see the shadow of a predator in tall grass or recognize the signs of an approaching storm. Today, that same instinct pushes us to find coherence in the randomness of the cosmos. When confronted with 2 anomalies like the WOW signal and 3 Atlas, our minds struggle to accept that they might be unconnected. The coincidences feel too sharp, too orchestrated, too meaningful to dismiss. 2 events separated by nearly half a century, both traced back to the same region of sky, both resisting easy explanation. One was a whisper in radio frequencies, the other a tangible visitor from interstellar space. To many, the pairing suggests design, as though the signal was a greeting and the comet the follow-up, or as though both were pieces of a puzzle yet to be solved. But science demands restraint. To leap from coincidence to contact without evidence is to risk turning curiosity into fantasy. The WOW signal, for all its intrigue, has never repeated. Its exact position remains uncertain within several arc minutes. 3 Atlas's radiant covers a swath of sky a few degrees across. In cosmic terms, that translates to distances of light years. From that perspective, the alignment is not as precise as our pattern-seeking minds want to believe. Millions of stars lie in that direction, countless possible origins. To link them too tightly risks overstating the connection. Timing complicates matters further. If 3 Atlas has been wandering the galaxy for millions of years since its ejection from some distant system, its arrival now may simply be chance. The WOW signal could have been a transient maser flare from a hydrogen cloud, completely unrelated to any object. Both anomalies may share only the fact that humans noticed them. Yet our minds resist this conclusion. The universe is nearly 14 billion years old. Our species has been listening for signals for less than a century. What are the odds that 2 unrelated phenomena would appear within that brief window? This psychological tension has long haunted the search for extraterrestrial intelligence. We are caught between skepticism and hope. On one side lies the scientific requirement to avoid overinterpreting chance alignments. On the other lies the deeply human yearning not to be alone. When the evidence is ambiguous, as it so often is, we lean toward the interpretation that resonates most with our desires. For some, that means clinging to coincidence as the safest explanation. For others, it means entertaining the possibility of contact, however faint. Philosophers call this the problem of induction, the difficulty of drawing general conclusions from limited observations. With only one unexplained radio signal and 3 interstellar objects in human history, our sample size is too small for reliable statistics. Are such events common or rare? Do they cluster or disperse? We simply do not know. Until we build a much larger catalog of anomalies, each new case will feel more significant than it may truly be. Yet dismissing the correlation entirely requires its own leap of faith. In a galaxy with hundreds of billions of stars, perhaps intelligent life is more common than we assume. If even a fraction of civilizations attempt interstellar communication, then coincidences may not be coincidences at all but the faint outlines of a network we are only beginning to glimpse. From this perspective, the WOW signal and 3 Atlas could be 2 notes in a cosmic symphony, barely audible to us now but hinting at a larger score. This duality, coincidence or contact, fuels both scientific inquiry and public imagination. Scientists design experiments to test the possibilities, searching for radio emissions from 3 Atlas, monitoring its motion for non-gravitational accelerations, analyzing its chemistry for unnatural ratios. The public consumes documentaries and news articles, captivated by the idea that a comet could be a messenger. Both groups are driven by the same question: what if it is not just coincidence? The irony is that science advances whether the anomalies prove connected or not. If they are unrelated, the exercise still teaches us about the diversity of interstellar matter and the challenges of detecting signals amid cosmic noise. If they are connected, the implications would be revolutionary, forcing us to reconsider our place in the universe. Either way, the process of asking, testing, and refining deepens our understanding. Still, the emotional weight of the question cannot be denied. To imagine that another intelligence might have chosen to signal us, first with a burst of radio at the hydrogen line, then with a physical object decades later, is to imagine that we are not isolated in the cosmic dark. It is to imagine that someone is watching, waiting, perhaps even reaching out. Such thoughts inspire awe, but they also demand caution. History warns us that anomalies often yield to mundane explanations once enough data accumulates. Pulsars, gamma-ray bursts, fast radio bursts, all were once contenders for alien origin until natural processes were revealed. And yet, the WOW signal still stands apart, stubbornly unexplained, resistant to dismissal. 3 Atlas now stands beside it, a second anomaly from the same sky. Together, they form a story too compelling to ignore, even if the ending remains unwritten. Perhaps the coincidence is just that, coincidence. But perhaps, just perhaps, it is the first faint trace of contact. In the next part, we will explore one of the most daring ideas born from this pairing, the message in motion hypothesis. What if the WOW signal was not the end of the story but the beginning, a radio announcement followed by a physical follow-up? Could 3 Atlas be more than a rock? Could it be a messenger on a mission across decades and light years? The act of listening has always been at the core of humanity's search for company in the cosmos. From the moment radio telescopes were first pointed at the sky, astronomers have wondered if someone might be out there broadcasting a signal across the void. For decades the effort was modest, often underfunded, and sometimes ridiculed. But the arrival of 3 Atlas changed that. For the first time, we had a tangible interstellar visitor whose trajectory and timing seemed almost scripted. If there was ever a moment to listen carefully, this was it. By mid-2025, a global network of observatories had begun coordinating the most ambitious SETI campaign in history. The strategy was simple in concept but daunting in execution: monitor 3 Atlas across as much of the electromagnetic spectrum as possible, at as many times as possible, with as many instruments as possible. The goal was to leave no opportunity untested, no frequency unexplored, no anomaly unnoticed. The first key window would arrive with the Mars flyby in early October. At a distance of 30 million kilometers, the comet would be close enough for spacecraft orbiting Mars to conduct stereo observations. While those spacecraft were not designed for radio SETI, their instruments could provide valuable context about the object's environment. Simultaneously, radio telescopes on Earth prepared to watch. If 3 Atlas was programmed to activate near-planetary encounters, Mars might be the trigger. The second window, late October, coincided with perihelion. As the comet swung closest to the Sun, its chemistry would be pushed to extremes. Some speculated that this stress might activate hidden systems, either natural or artificial. The challenge, of course, was visibility. From Earth, the object would be lost in the glare of the Sun. Only space-based telescopes with protective shielding could monitor it. Radio arrays, however, would not be blinded, and they planned to listen continuously. The third and most critical window came with the Earth flyby in December. At 270 million kilometers, the object would be twice as far as the Sun but still relatively near by cosmic standards. For radio astronomers, this was ideal. Any emissions would be stronger at that distance than at any other point in the comet's trajectory. Moreover, Earth's rotation would allow continuous monitoring, as different telescopes around the globe picked up the baton in a relay of vigilance. The listening campaign focused heavily on the so-called water hole, the quiet band between hydrogen at 1420 MHz and hydroxyl at around 1660 MHz. This was the frequency range SETI researchers had long identified as the most logical place for interstellar communication. Within that band lay the hydrogen line itself, the exact frequency of the WOW signal. If 3 Atlas had anything to say, this was where we expected to hear it. But the search did not stop there. Modern SETI projects have expanded their scope dramatically, scanning millions of channels across gigahertz of bandwidth. Algorithms comb through data in real time, flagging narrowband signals, frequency drifts, and modulation patterns that might indicate intelligence. Facilities like the Green Bank Telescope in West Virginia, the Meerkat Array in South Africa, and the Parkes Observatory in Australia joined forces. Together, they provided nearly round-the-clock coverage. China's FAST telescope added another dimension. As the largest single-dish radio telescope on Earth, its sensitivity to faint signals was unmatched. FAST's operators dedicated significant observing time to monitoring 3 Atlas, combing the hydrogen line with a precision no other facility could match. If even the faintest transmission existed, FAST stood the best chance of detecting it. Signal processing posed its own challenges. Natural cosmic phenomena can mimic artificial signals with surprising accuracy. Hydrogen masers, plasma interactions, and even reflections from satellites can produce narrowband emissions. Distinguishing between the natural and the artificial required careful analysis of frequency stability, polarization, and repetition. Genuine technology, scientists argued, would reveal itself through structure, patterns that nature rarely produces. The campaign also incorporated optical and infrared searches. Pulsed laser communication, while speculative, remains a possibility. Sensitive instruments scan for flashes of coherent light, brief bursts that might carry information across space. Infrared detectors watched for unusual thermal signatures, perhaps localized heat sources that could betray internal power systems. Though less likely than radio, these methods added layers of redundancy. Citizen science played a surprisingly large role. Amateur astronomers, armed with increasingly sophisticated equipment, joined the effort through distributed networks. Some contributed optical monitoring, tracking brightness variations that might correlate with radio events. Others processed chunks of radio data using platforms reminiscent of the old SETI at Home project. The result was a truly global effort, uniting professionals and amateurs in a shared mission to listen. Psychologically, the campaign carried immense weight. Everyone knew the odds were long. The vast majority of scientists expected silence. But the possibility of a signal, however remote, was enough to inspire vigilance. Protocols were in place should anything extraordinary emerge. Any candidate signal would need to be verified by multiple independent telescopes, ruling out local interference. Only then would the discovery be announced. The process was designed to prevent false alarms, but also to ensure that if something genuine appeared, it could not be dismissed. Even silence would have meaning. If no signals were detected, it would strengthen the case for natural origin. It would also set limits, showing that if the object was technological, it was not broadcasting at detectable levels on the frequencies we monitored. Those constraints would guide future searches, refining our understanding of what to expect. In science, null results can be just as valuable as detections. For the public, however, the narrative was irresistible. Headlines spoke of Earth listening for alien messages. Documentaries framed the campaign as humanity's most dramatic attempt yet to make contact. Social media buzzed with speculation about when, not if, the signal would arrive. Scientists tried to temper expectations, but the allure of the story was too strong. After all, who would not want to be alive at the moment humanity heard from another intelligence? As December approached, the tension grew. Telescopes stood ready, their dishes tilted toward the sky. Algorithms were primed, data storage prepared for an onslaught of information. In control rooms and living rooms alike, people waited. The comet itself streaked silently on its path, indifferent to the hopes it carried. Whether messenger or rock, probe or wanderer, 3 Atlas had become a focal point for humanity's greatest question. In the next part, we will widen the lens. Beyond the immediate search, what does 3 Atlas tell us about the bigger picture of interstellar visitors, planetary system formation, and the interconnectedness of the galaxy itself? 3 Atlas may or may not carry messages from another intelligence, but whatever its ultimate nature, its scientific value is beyond question. Interstellar visitors are time capsules, fragments of alien planetary systems ejected into space and set adrift for millions of years before crossing our path. Each one is a messenger, not necessarily of intention, but of history, history written in chemistry, structure, and motion. To study them is to study worlds we may never see directly. For decades, scientists assumed interstellar objects would be vanishingly rare. The distances are vast, the odds of one wandering into our solar system seemed remote. Then came Oumuamua in 2017, a bizarre, elongated shape that accelerated as though pushed by some invisible hand. Just 2 years later, Borisov appeared, a more conventional comet but still alien in its chemistry. Now, only a few years later, 3 Atlas has joined the list. 3 objects in less than a decade forced a dramatic shift in thinking. Instead of rare flukes, interstellar visitors may be common. With the right surveys, we may detect dozens, even hundreds, in the years ahead. Each object is an archive. Oumuamua hinted at physics we still do not fully understand. Borisov revealed differences in volatile compositions, proof that planetary systems form with striking variety. 3 Atlas, with its dominance of carbon dioxide and its nickel without iron, may point to environments fundamentally unlike anything in our system. These discoveries expand our sense of what is possible, reminding us that the Milky Way is more diverse than our local sample of rocks and comets suggests. Beyond chemistry, interstellar visitors offer clues about planetary system dynamics. To be ejected into interstellar space, a comet or asteroid must experience powerful gravitational encounters, perhaps with a giant planet, perhaps during the violent early years of system formation. Each interstellar object we study is a survivor of such encounters, carrying evidence of how planets interact and evolve. In a sense, they are fossils of cosmic architecture. By piecing together their properties, we can reconstruct the hidden history of alien systems. 3 Atlas, with its retrograde orbit nearly aligned with our ecliptic, adds another wrinkle. Its trajectory suggests it may have been shaped by galactic dynamics, nudged over millions of years by gravitational tides and encounters with passing stars. Tracing its path backward may reveal not just a point of origin but the story of how interstellar space itself sculpts wandering matter. In this way, the comet becomes a probe, not of intelligence, but of galactic history. The bigger picture extends even further, into the realm of astrobiology. If comets can carry complex organics, and we know they can, then interstellar comets may carry them between systems. The idea of panspermia, life spreading from star to star via natural carriers, remains controversial. Yet every interstellar visitor adds weight to the possibility. If microorganisms can survive the journey, frozen and shielded within a nucleus, then interstellar comets may be seeds, scattering life across the galaxy. 3 Atlas shows no signs of biology, but future visitors may. One discovery of preserved organics, or even fossilized microbes, would revolutionize our understanding of life's distribution. Equally important are the technological lessons. The campaign to observe 3 Atlas has forced astronomers to coordinate across continents, instruments, and wavelengths. It has demanded rapid response, flexible scheduling, and new algorithms for analyzing transient phenomena. These advances will not vanish when the comet departs. They will strengthen astronomy itself, preparing us for future surprises. In this sense, the object is a teacher as much as a subject. Citizen science is another dimension of this bigger picture. The rise of networks that allow amateurs to contribute data, monitor brightness, and process radio signals has democratized astronomy in ways unthinkable a generation ago. 3 Atlas became not only a scientific target but a public project, inviting participation from anyone with a telescope or a computer. That shared ownership may be one of its most lasting legacies, inspiring a new generation to look up and wonder. Philosophically, 3 Atlas challenges us in subtler ways. Its anomalies remind us of how little we know. For centuries, humans assumed our solar system was typical. Our planets, our comets, our chemistry, surely these reflected the norm. But interstellar visitors tell a different story. They suggest diversity beyond imagining. If every system produces wanderers with distinct fingerprints, then the galaxy is a mosaic of possibilities, each piece shaped by unique conditions. In that context, our home is not a model but a single example among billions. This humility matters. It prepares us for the unknown. Whether the WOW signal and 3 Atlas are connected or not, both force us to confront mysteries that resist easy answers. Both push us to refine our tools, to question our assumptions, to embrace uncertainty. In doing so, they embody the best of science, not certainty, but curiosity. Looking ahead, the legacy survey of space and time at the Vera Rubin Observatory promises to transform this field. Beginning later this decade, it will scan the sky with unprecedented depth and speed, detecting countless moving objects. Interstellar visitors that once slipped past unnoticed will be caught in the act. Within a few years, we may have a statistical population large enough to answer the questions 3 Atlas raises. Are carbon dioxide-rich comets common? Do nickel-rich but iron-poor bodies appear elsewhere? Is retrograde motion an accident or a clue? The data will tell us. But the bigger picture is not just about numbers. It is about perspective. 3 Atlas reminds us that our solar system is not an island. We are part of a galaxy alive with exchange. Rocks and ice, dust and organics, even life itself may move from star to star, linking worlds in ways we are only beginning to appreciate. In that sense, every interstellar visitor is part of a network, a cosmic web binding the Milky Way into something greater than the sum of its parts. In the next part, we will return from the scientific to the human. Beyond chemistry and dynamics, beyond SETI and surveys, lies a deeper reflection. What does it mean, at this moment in history, to stand on the threshold of mysteries like these? What does 3 Atlas tell us not just about the cosmos, but about ourselves, our curiosity, and our readiness for whatever comes next? To stand under the night sky is to feel small, yet also strangely significant. The stars remind us of our fragility, but they also ignite our imagination. Throughout history, every culture has looked upward and asked the same questions. Who else is out there? Are we alone in this vastness? What does it mean if we are not? The WOW signal in 1977 and the arrival of 3 Atlas in 2025 are not just scientific curiosities. They are mirrors, reflecting back our deepest yearnings and our restless hunger for connection. Consider the timing. Humanity in 1977 was at the dawn of the digital era, sending probes to the outer planets, broadcasting our first tentative messages into space. The WOW signal landed like a jolt of electricity in that moment, a reminder that the universe might already be aware of us. Nearly 50 years later, in 2025, we are more technologically advanced, globally connected, and scientifically sophisticated. Yet the questions remain the same. 3 Atlas arrives to find us still listening, still searching, still hoping. These events touch something primal. The desire to know we are not alone is one of the oldest stories we tell ourselves. From ancient myths of gods descending from the heavens to modern science fiction of interstellar visitors, we have always imagined company in the stars. The WOW signal and 3 Atlas are not definitive answers, but they are tantalizing hints that keep the dream alive. They remind us that the universe is not silent, not simple, and perhaps not indifferent. At the same time, they test our maturity. How ready are we for an answer? If 3 Atlas were to reveal itself as a probe, how would we react? With wonder, fear, suspicion, awe. Our species has struggled even to live peacefully with itself. Would we be capable of meeting another intelligence with humility and respect? These are not questions for astronomers alone. They are questions for all of us, because the discovery of life beyond Earth would change everything: our religions, our philosophies, our politics, even our sense of identity. For now, we are left in suspense, and perhaps that is a gift. Suspense sharpens curiosity. It keeps us watching, listening, preparing. In many ways, the waiting is as important as the finding. The WOW signal taught us to expect the unexpected. 3 Atlas teaches us to be ready for follow-ups we cannot anticipate. Together, they train us to hold contradictions in our minds, mystery and evidence, coincidence and meaning, skepticism and wonder. There is a rhythm to this search. Decades of silence punctuated by moments of anomaly. Long stretches of nothing, then 72 seconds of wow. Centuries of routine astronomy, then a sudden interstellar comet that refuses to fit the mold. These moments are like drumbeats in a song too long for us to hear in full. We catch fragments, hints of melody, and spend lifetimes trying to piece together the larger composition. Psychologists call this the pattern hunger of the human brain. We are uncomfortable with randomness. We prefer stories, arcs, causes, and effects. But perhaps that hunger is what drives science itself. We look at the sky not just to measure it but to narrate it. The WOW signal is part of our story. So is 3 Atlas. Even if they turn out to be unconnected, they have already woven themselves into our collective myth, joining the pantheon of mysteries that keep us awake at night. And maybe that is the point. The universe may not owe us answers, but it keeps giving us questions. Each one propels us further. The WOW signal pushed SETI to refine its methods, to take the search seriously. 3 Atlas pushes planetary science to broaden its imagination, to consider diversity beyond our local sample. The interplay between mystery and method is how knowledge grows. There is also a humility here. We are new at this. Our species has had radio telescopes for less than a century. We have only just begun to explore interstellar space with probes like Voyager. We are infants in galactic terms, just learning to crawl. To expect immediate, unambiguous answers may be arrogant. Perhaps the cosmos communicates in a language we have not yet learned to hear. Perhaps the real message is not a single signal or object, but the cumulative effect of anomalies that force us to grow. Still, hope lingers. Every time a telescope turns toward 3 Atlas, every time data flows into servers, there is a sliver of possibility that the universe will speak more clearly. Maybe it will be silence. Maybe it will be a natural explanation, as so many mysteries before. But maybe, just maybe, it will be something else, a pattern undeniable, a signal unmistakable. The waiting is heavy, but it is also exhilarating. To live in this moment, to be the generation that might catch the next wow, is to feel the pulse of history. As December 2025 approaches, when 3 Atlas will make its closest pass, the sense of anticipation grows. Scientists, journalists, enthusiasts, and dreamers all share in the same vigil. We wait not just for data but for meaning. We wait for a story larger than ourselves, one that stretches from a radio telescope in Ohio to a comet racing through our skies nearly half a century later. We wait, as humanity has always waited, for the stars to answer. In the next part, we will look ahead to those crucial months of encounter, Mars, the Sun, Earth, and Jupiter, and consider the scenarios scientists have outlined. What would count as proof of natural origin? What would count as evidence of something more? And how would we tell the difference? By the time autumn of 2025 arrived, the scientific community had sketched out a set of scenarios for how 3 Atlas might behave during its passage. They ranged from the utterly mundane to the potentially revolutionary. Each depended on how the comet responded to the heat of the Sun, the pull of planets, and the scrutiny of instruments turned upon it. The stakes were high not because of what was likely, but because of what was possible. For once, humanity had a checklist that might distinguish coincidence from contact. The most conservative scenario was also the most probable: 3 Atlas would behave like a comet. It would brighten steadily as it approached the Sun, venting gas and dust in response to rising temperatures. Its tail would lengthen, its coma would swell, and then after perihelion it would fade as it retreated into the cold. The chemistry would remain unusual but ultimately explicable, chalked up to the diversity of exoplanetary nurseries. In this version of the story, the mystery resolved not into contact but into context, evidence that our galaxy produces more variety than we had imagined. A second scenario was more dramatic but still natural: fragmentation. Comets are fragile. Many cannot survive close passes to stars. Heat cracks their crusts, pressure builds, and nuclei split apart. Astronomers remembered Comet Ison in 2013, hailed as a possible comet of the century, only to disintegrate near the Sun. If 3 Atlas fractured at perihelion, it would provide new opportunities to study its interior. The nickel without iron might be explained by layered composition. The dominance of carbon dioxide might be clarified by hidden reservoirs exposed by the break. But fragmentation would also mean the comet's mysteries might scatter into dust before we could fully understand them. The third scenario pushed into less comfortable territory: non-gravitational acceleration. This was the puzzle of Oumuamua in 2017, which had inexplicably sped up as though pushed by a faint thrust. Some argued that outgassing of invisible hydrogen could explain it, but others suggested thinner, more exotic possibilities, perhaps even artificial propulsion. If 3 Atlas displayed similar accelerations that could not be attributed to natural jets, the debate would ignite instantly. Every telescope in the world would scramble to confirm. A comet changing course in ways inconsistent with physics would be impossible to ignore. The fourth scenario was the most extraordinary: transmission. If 3 Atlas emitted structured radio signals, especially at the hydrogen line, the implications would be seismic. Protocols existed, carefully drafted over decades, for how to handle such a discovery. Independent confirmation by multiple observatories would be required. Once verified, the information would be made public. The International Academy of Astronautics had outlined procedures for notifying the United Nations and world governments. But no one really knew how humanity would react. Would there be panic, awe, denial, celebration? The world had never faced such a test. Between these poles lay countless possibilities. 3 Atlas might display strange brightness fluctuations that hinted at internal structures. It might outgas compounds never before seen, challenging our models of chemistry. It might interact with planetary magnetic fields in ways we do not expect. Each anomaly would add fuel to debate, each would test the boundary between natural and artificial explanations. What counted as proof was itself contested. For skeptics, nothing short of an unambiguous transmission would suffice. For others, Patterns of anomalies could accumulate into a kind of circumstantial case, the way archaeologists infer intention from the shape of ancient tools. A comet that acted too much like a probe might, in time, be accepted as one. But science is slow to leap. Extraordinary claims require extraordinary evidence, and extraordinary evidence is hard to come by when an object is slipping out of reach forever. The Mars flyby in October was treated as the dress rehearsal. If anything unusual occurred, unexpected accelerations, signals, or chemistry shifts, it would shape expectations for perihelion and Earth's flyby. Nothing dramatic emerged, though data analysis was ongoing. That absence of fireworks calmed some nerves but raised others. If the object was artificial, perhaps it was waiting. Waiting for the right proximity, the right geometry, the right moment to speak. Perihelion at the end of October was the crucible. Comets reveal their secrets under heat. If 3 Atlas carried hidden materials or structures, the sun's intensity might force them into view. Astronomers watched with every instrument they could muster, prepared for either spectacular fragmentation or unexpected resilience. Some even speculated that perihelion might serve as a trigger. If the object were engineered, it might be designed to activate under solar stress. That notion was dismissed by most, but it lingered in the background of public imagination. December 19th loomed as the climax. The closest approach to Earth meant the best chance for radio monitoring. SETI campaigns worldwide tuned in, their algorithms ready to sift petabytes of data. Some teams quietly admitted that if nothing appeared during this window, the artificial hypothesis would lose much of its plausibility. If the wow signal had been the opening note, surely the comet's flyby would be the chorus. Silence then would be deafening. Jupiter's encounter in March 2026 added a final chapter. If the comet interacted strangely with the giant planet's magnetic field, or if its trajectory shifted in unexpected ways, questions would persist. But after Jupiter, the object would fade. There would be no second act. The window would close forever. These scenarios were more than speculation. They were guideposts for analysis. Every possibility demanded preparation, instruments calibrated, algorithms tested, protocols rehearsed. Scientists knew that discovery favored the prepared mind. If something extraordinary occurred, they needed to be ready, not scrambling. That readiness was itself a measure of how far SETI and planetary science had come since 1977. The wow signal had caught us off guard. 3 Atlas would not. The tension lay in the fact that all outcomes mattered. If 3 Atlas behaved normally, it would still enrich our understanding of interstellar chemistry. If it fragmented, it would reveal interior structures. If it accelerated anomalously, it would challenge our physics. If it transmitted, it would transform our civilization. In every case, the comet carried meaning. The only unacceptable outcome would be indifference. And so humanity waited. Scientists drew up scenarios not only for behavior but for response. What would they say if a signal was detected? How would they communicate results without causing panic? How would governments react, or the markets, or religions? These questions, once abstract, now felt immediate. 3 Atlas forced us to consider not only the science but the sociology of discovery. In the next part, we will step into that sociological space. Beyond telescopes and data, how would humanity actually respond if contact were confirmed? What does our history of reaction to the unknown suggest about our readiness for the most profound discovery of all? By the time autumn of 2025 arrived, the scientific community had sketched out a set of scenarios for how 3 Atlas might behave during its passage. They ranged from the utterly mundane to the potentially revolutionary. Each depended on how the comet responded to the heat of the sun, the pull of planets, and the scrutiny of instruments turned upon it. The stakes were high not because of what was likely, but because of what was possible. For once, humanity had a checklist that might distinguish coincidence from contact. The most conservative scenario was also the most probable: 3 Atlas would behave like a comet. It would brighten steadily as it approached the sun, venting gas and dust in response to rising temperatures. Its tail would lengthen, its coma would swell, and then after perihelion it would fade as it retreated into the cold. The chemistry would remain unusual but ultimately explicable, chalked up to the diversity of exoplanetary nurseries. In this version of the story, the mystery resolved not into contact but into context, evidence that our galaxy produces more variety than we had imagined. A second scenario was more dramatic but still natural: fragmentation. Comets are fragile. Many cannot survive close passes to stars. Heat cracks their crusts, pressure builds, and nuclei split apart. Astronomers remembered Comet Ison in 2013, hailed as a possible comet of the century, only to disintegrate near the Sun. If 3 Atlas fractured at perihelion, it would provide new opportunities to study its interior. The nickel without iron might be explained by layered composition. The dominance of carbon dioxide might be clarified by hidden reservoirs exposed by the break. But fragmentation would also mean the comet's mysteries might scatter into dust before we could fully understand them. The third scenario pushed into less comfortable territory: non-gravitational acceleration. This was the puzzle of Oumuamua in 2017, which had inexplicably sped up as though pushed by a faint thrust. Some argued that outgassing of invisible hydrogen could explain it, but others suggested thinner, more exotic possibilities, perhaps even artificial propulsion. If 3 Atlas displayed similar accelerations that could not be attributed to natural jets, the debate would ignite instantly. Every telescope in the world would scramble to confirm. A comet changing course in ways inconsistent with physics would be impossible to ignore. The fourth scenario was the most extraordinary: transmission. If 3 Atlas emitted structured radio signals, especially at the hydrogen line, the implications would be seismic. Protocols existed, carefully drafted over decades, for how to handle such a discovery. Independent confirmation by multiple observatories would be required. Once verified, the information would be made public. The International Academy of Astronautics had outlined procedures for notifying the United Nations and world governments. But no one really knew how humanity would react. Would there be panic, awe, denial, celebration? The world had never faced such a test. Between these poles lay countless possibilities. 3 Atlas might display strange brightness fluctuations that hinted at internal structures. It might outgas compounds never before seen, challenging our models of chemistry. It might interact with planetary magnetic fields in ways we do not expect. Each anomaly would add fuel to debate, each would test the boundary between natural and artificial explanations. What counted as proof was itself contested. For skeptics, nothing short of an unambiguous transmission would suffice. For others, patterns of anomalies could accumulate into a kind of circumstantial case, the way archaeologists infer intention from the shape of ancient tools. A comet that acted too much like a probe might, in time, be accepted as one. But science is slow to leap. Extraordinary claims require extraordinary evidence, and extraordinary evidence is hard to come by when an object is slipping out of reach forever. The Mars flyby in October was treated as the dress rehearsal. If anything unusual occurred, unexpected accelerations, signals, or chemistry shifts, it would shape expectations for perihelion and Earth's flyby. Nothing dramatic emerged, though data analysis was ongoing. That absence of fireworks calmed some nerves but raised others. If the object was artificial, perhaps it was waiting. Waiting for the right proximity, the right geometry, the right moment to speak. Perihelion at the end of October was the crucible. Comets reveal their secrets under heat. If 3 Atlas carried hidden materials or structures, the sun's intensity might force them into view. Astronomers watched with every instrument they could muster, prepared for either spectacular fragmentation or unexpected resilience. Some even speculated that perihelion might serve as a trigger. If the object were engineered, it might be designed to activate under solar stress. That notion was dismissed by most, but it lingered in the background of public imagination. December 19 loomed as the climax. The closest approach to Earth meant the best chance for radio monitoring. SETI campaigns worldwide tuned in, their algorithms ready to sift petabytes of data. Some teams quietly admitted that if nothing appeared during this window, the artificial hypothesis would lose much of its plausibility. If the wow signal had been the opening note, surely the comet's flyby would be the chorus. Silence then would be deafening. Jupiter's encounter in March 2026 added a final chapter. If the comet interacted strangely with the giant planet's magnetic field, or if its trajectory shifted in unexpected ways, questions would persist. But after Jupiter, the object would fade. There would be no second act. The window would close forever. These scenarios were more than speculation. They were guideposts for analysis. Every possibility demanded preparation, instruments calibrated, algorithms tested, protocols rehearsed. Scientists knew that discovery favored the prepared mind. If something extraordinary occurred, they needed to be ready, not scrambling. That readiness was itself a measure of how far SETI and planetary science had come since 1977. The wow signal had caught us off guard. 3 Atlas would not. The tension lay in the fact that all outcomes mattered. If 3 Atlas behaved normally, it would still enrich our understanding of interstellar chemistry. If it fragmented, it would reveal interior structures. If it accelerated anomalously, it would challenge our physics. If it transmitted, it would transform our civilization. In every case, the comet carried meaning. The only unacceptable outcome would be indifference. And so humanity waited. Scientists drew up scenarios not only for behavior but for response. What would they say if a signal was detected? How would they communicate results without causing panic? How would governments react, or the markets, or religions? These questions, once abstract, now felt immediate. 3 Atlas forced us to consider not only the science but the sociology of discovery. In the next part, we will step into that sociological space. Beyond telescopes and data, how would humanity actually respond if contact were confirmed? What does our history of reaction to the unknown suggest about our readiness for the most profound discovery of all? Silence can be profound. In music, silence gives shape to sound. In conversation, silence can be as revealing as words. In the search for extraterrestrial intelligence, silence has often been taken as discouragement, the absence of company in the dark. But silence, too, carries meaning. If 3 Atlas completes its passage through our solar system without a whisper of radio, without a flicker of artificiality, that silence will not be failure. It will be lesson. Imagine the comet sweeping past Mars, rounding the Sun, gliding past Earth, then fading beyond Jupiter with nothing more than natural behavior. No signals at the hydrogen line. No strange accelerations. No hidden structures revealed by fragmentation. Just carbon dioxide and dust, tails of gas and sunlight scattering particles into space. For many, that outcome would feel anticlimactic, the deflation of years of speculation. But for scientists, it would be invaluable. For one, it would confirm the extraordinary diversity of planetary systems. The chemical oddities of 3 Atlas, its carbon dioxide dominance, its nickel without iron, its overperformance relative to size, would still require explanation. Silence would not erase those puzzles, it would sharpen them. Instead of being artifacts of technology, they would become clues to environments and processes far beyond our solar experience. Each anomaly would point back to conditions in an alien nursery, teaching us about the physics of worlds we will never see. Silence would also refine our expectations. In SETI, every null result is data. Each time we listen and hear nothing, we set new limits on what might be out there. If 3 Atlas carried no signals, then either it was not artificial, or it was transmitting in ways we cannot detect. Both conclusions matter. They force us to widen our methods, to consider channels beyond radio and optical. Perhaps communication occurs in neutrinos, or gravitational waves, or mediums we have not yet imagined. Silence pushes innovation. There is also the psychological lesson. Silence teaches patience. Humanity has only just begun its search. Less than a century of listening is nothing against cosmic timescales. Civilizations may rise and fall in spans of thousands or millions of years. We may simply not overlap with their transmissions. Silence reminds us that discovery may require not just decades, but centuries of persistence. It humbles us into recognizing that the universe does not operate on human schedules. For some, silence will deepen doubt. They will argue that the WOW signal was a fluke, that 3 Atlas was just a rock, that SETI is chasing ghosts. Funding may waver, enthusiasm may fade. But history shows that silence does not end exploration. The early years of radio astronomy were filled with noise and confusion, yet persistence led to pulsars, quasars, cosmic microwave background, discoveries that reshaped science. Silence did not mean absence, it meant waiting for the right tools. Philosophically, silence has its own beauty. It reminds us that the universe is vast and indifferent, yet still full of wonder. We do not need aliens to be astonished by reality. The fact that comets can wander between stars, carrying the fingerprints of alien chemistry, is miracle enough. The fact that we can detect them, study them, debate them, shows how far we have come as a species. Silence does not diminish that miracle, it frames it. There is also resilience in silence. The absence of signals means the responsibility remains ours. We cannot wait for others to teach us, to guide us, to save us. We must grow on our own, build our own solutions to planetary crises, chart our own future in the stars. Silence is a challenge, to mature without confirmation, to act as though we are alone, while still hoping we are not. And perhaps silence is not silence at all. Perhaps it is simply misunderstanding. A message may be encoded in ways we do not recognize, carried by physics we have yet to master. The WOW signal might have been such a message, incomprehensible to us now but clear in a future when our science advances. 3 Atlas might carry structures we cannot yet detect. What feels like silence may later be revealed as conversation, waiting for us to learn the language. In this way, silence keeps the door open. It is not rejection. It is invitation. The invitation to keep building bigger telescopes, to keep refining algorithms, to keep asking questions. The invitation to stay curious even when answers are withheld. The invitation to prepare ourselves for the day when silence breaks. 3 Atlas, if it proves natural, will join Oumuamua and Borisov as stepping stones. Each one nudges us forward, teaching us that the galaxy is full of wanderers, each carrying unique lessons. None need be probes for them to matter. They expand our sense of the possible, remind us that we are part of a vast network of exchange, even if no one is calling our name. In the end, silence may be the most powerful teacher. It keeps us honest, forcing us to separate hope from evidence. It keeps us humble, reminding us of our infancy as a species. And it keeps us searching, because silence is never the final word. In the next part, we will move toward the conclusion of this journey. We will consider the legacy of the WOW signal and 3 Atlas together, how they will be remembered, and what they mean for the future of humanity's search for meaning in the stars. Legacies are not always born of answers. Often they are born of questions that refuse to die. The WOW signal and 3 Atlas, separated by nearly half a century, may share no causal link at all, yet together they have carved out a place in the story of humanity's search for meaning in the stars. Their true significance may not be in what they were, but in what they forced us to confront. The WOW signal's legacy lies in its purity. 72 seconds of narrowband intensity, centered almost exactly on the hydrogen line, with a profile that looked exactly like what SETI had always predicted. It was as if someone had handed us the textbook definition of an interstellar signal, then snatched it away before we could take a second look. That one detection galvanized a field that was, at the time, struggling for legitimacy. It proved that anomalies could happen, that vigilance could pay off. Even without repetition, it became a touchstone, a reminder that the universe sometimes whispers and that we must be ready to listen. 3 Atlas's legacy may prove similar. Whether it is ultimately remembered as a peculiar comet or something more, it has already shifted our perspective. It reminded us that interstellar visitors are not rare curiosities but part of the galaxy's natural traffic. It demonstrated that chemical diversity extends beyond our imagination. And it showed us how swiftly science, media, and public imagination can converge on a single object, transforming a faint smudge of light into a global story. Together, the two events frame a narrative arc, the fleeting signal and the enduring visitor. One was ephemeral, gone before we could respond. The other is tangible, measurable, studied from every angle. Both invite speculation. Both resist closure. In that way, they complement each other, each highlighting the limits of our methods. Radio telescopes cannot replay the past. Comets cannot easily reveal their hidden histories. But taken together, they encourage us to expand our toolkit, to think more broadly about what evidence might look like. The WOW signal taught SETI that one-off events can be powerful enough to shape generations of research. 3 Atlas teaches planetary science that anomalies can redefine assumptions about formation and chemistry. Their shared legacy is not proof of aliens but proof of humility. Proof that we are still students in a classroom far larger than Earth. Culturally, their impact reaches further. Both have entered the realm of story. The WOW signal is cited in documentaries, novels, and films as the moment we nearly made contact. Its red circle printout is an icon, a symbol of curiosity unmet. 3 Atlas, though newer, has already taken on similar weight. Media frame it as a possible messenger, a cosmic stranger from Sagittarius. For millions of people who will never read a technical paper, these stories matter more than the data. They keep the mystery alive, woven into the collective imagination. The danger, of course, is overinterpretation. Anomalies can seduce us into certainty. Some will always insist the WOW signal was proof of aliens, others that 3 Atlas is a disguised probe. Science resists such leaps. But science also thrives on mystery, and the legacy of these events will not be diminished by caution. If anything, their power lies in remaining unresolved. The open question is what makes them enduring. They also highlight the importance of preparation. The WOW signal caught us unprepared, with technology too crude to confirm or deny. 3 Atlas finds us better equipped, global telescope networks, sophisticated algorithms, space observatories like Hubble and Webb, and even the possibility of spacecraft coordination. The legacy here is that we are learning to be ready. Each anomaly sharpens our vigilance, building infrastructure for the day when ambiguity ends. Looking forward, the real legacy may be the inspiration they provide. Young scientists drawn to astronomy often cite the WOW signal as the spark that lit their curiosity. 3 Atlas may do the same for a new generation. Children watching headlines about alien comets today may grow up to design the instruments that solve tomorrow's mysteries. In this sense, both anomalies seed the future, ensuring that the search continues long after they are gone. Even if silence persists, the WOW signal and 3 Atlas will remain markers along the road. They will be remembered as the anomalies that reminded us not to take the cosmos for granted. They will sit beside Oumuamua, Borisov, pulsars, fast radio bursts, phenomena that once seemed alien and forced us to expand our understanding. Some turned out to be natural, others remain unexplained. All have pushed us forward. Philosophically, the legacy is one of perspective. These events remind us that the universe does not revolve around our expectations. We imagine contact will be clear, decisive, unmistakable. But perhaps it will not be. Perhaps it will be whispers, coincidences, hints that accumulate over generations until the pattern becomes undeniable. Perhaps the WOW signal and 3 Atlas are part of that accumulation, threads in a tapestry too large to see up close. In the end, legacy is measured not by what we know but by what we continue to ask. The WOW signal left us asking whether we had been hailed once and only once. 3 Atlas leaves us asking whether messengers pass through more often than we realize. Together, they leave us asking whether we are on the brink of discovery or simply participants in a cosmic drama of curiosity without resolution. Either way, the questions endure, and that endurance is their gift. In the next and final part, we will bring the story full circle. We will return to the hook, to the question that has lingered since 1977. Coincidence or contact? The answer may not be clear, but what matters most is how we carry the question forward. And as with all great stories, we will end with an invitation, for reflection, for wonder, and for conversation. 48 years ago, a volunteer at an Ohio radio telescope circled 6 characters on a printout and wrote one word in the margin: wow. Nearly half a century later, a comet-like object swept in from interstellar space, carrying chemistry that defied our models and a trajectory that pointed to the same region of sky. 2 anomalies, 2 mysteries, 1 constellation. Coincidence, or contact? That question has hovered over this story from the beginning, and it remains with us now. If the WOW signal was nothing more than a natural hydrogen maser, it was still a moment that taught us to listen carefully. If 3 Atlas is nothing more than an unusual comet, it is still a fragment of an alien system, a piece of another star's history delivered to our doorstep. Natural or not, both events matter, because both remind us of the vastness of what we do not yet understand. And yet, the temptation persists to weave them together. The WOW signal as the opening note, 3 Atlas as the echo. A whisper in 1977, a messenger in 2025. Perhaps they are unrelated, chance alignments in a noisy galaxy. Or perhaps they are chapters of a story still unfolding, pieces of a message larger than we can yet perceive. Science demands caution. Imagination demands daring. Humanity thrives on both. The legacy of these mysteries is not proof, but possibility. They force us to confront the limits of our knowledge, to prepare for the unexpected, to ask questions we cannot yet answer. They remind us that the search for meaning in the cosmos is not a sprint but a vigil, a long watch under ancient skies. They remind us that silence is data, that anomalies are gifts, that even coincidence can be revelation. What matters most is how we respond. Do we dismiss anomalies as distractions, or do we treat them as invitations? Do we let silence breed cynicism, or do we let it sharpen our curiosity? The WOW signal and 3 Atlas ask us not for certainty but for attention, for the willingness to listen, to measure, to wonder. As 3 Atlas fades beyond Jupiter, it will leave behind no clear answers, only the residue of debate. But perhaps that is fitting. Contact, if it ever comes, may not be a single moment of revelation. It may be a tapestry of hints, anomalies, and near misses, woven together across generations until the pattern becomes undeniable. We may not be the ones to see it clearly, but we are the ones to carry the thread forward. In the end, whether coincidence or contact, whether whisper or messenger, the significance lies in the fact that we noticed. We noticed the 72 seconds in 1977. We noticed the faint point of light in 2025. We paid attention. That is the essence of science, and of humanity itself, the refusal to look away from the unknown. And so the story circles back to you. You, watching this, are part of the legacy. Your curiosity, your willingness to wonder, your choice to keep listening, that is what keeps the search alive. Whether the next WOW comes tomorrow or 1,000 years from now, it will belong not just to the astronomers who record it, but to all of us who dared to ask if we are alone. So what do you think? Was the WOW signal a coincidence, or the first call from another intelligence? Is 3 Atlas just another comet, or a messenger in disguise? I want to hear your thoughts. Share your perspective in the comments below. And if you've been as captivated by this mystery as I have, make sure to like this video, subscribe to the channel, and ring the bell so you don't miss the next chapter in humanity's search for answers. Because the story isn't over. The universe is still speaking. The question is, are we still listening?